All right, so it's possible to have more than one answer on these questions. I'm going to try to not do that on your real test for 7 through 12. Now, it says a block of dry ice is given a brief push, and a moment later, after the push is done, we want to know what forces act on the block. So if we give it a brief push, here's what will happen. It'll actually be moving to the right. Now let's look at the forces. Once I am done pushing that block, okay, the only forces that act are the gravity force or the weight force, same thing, and the normal force pointing up. So we're only going to have B and D acting. For 8, which of the following describes the motion of the block? Given that we are pushing it before, but now we are done pushing it, and the pushing has stopped and we're on a frictionless surface, that means it's going to move at a constant speed at a straight line forever. All right, we're going to pull this cart with a steady force. So the forces that act, we have here, let's draw a free body diagram. So we have the normal, we got the weight, and we have this tension force pulling it to the right. So that gives us A, B, and D. This force of motion is always a trick. There is no such thing in a problem. Just so you're aware. And then, which of the following describes the cart as it's moved with a steady force? It's pulled with a force. Force is mass times acceleration. It will actually accelerate constantly. Now, when the string breaks, the force is now dead. The car is already moving, so it wants to continue moving at constant speed. And then as the cart falls off the edge of the table, there is no friction, there is no normal force, there is no force of motion. There is only the force of gravity pulling down on the cart. Okay. Then number 13, what is the difference between weight and force of gravity? Do not be tricked. These are 100% identical forces. Okay. Then an object is pushed on an ordinary table at constant velocity. The pushing force is removed. What happens to the object and why? Well, if we remove the pushing force, let's just draw the free body diagram. We're going to have a normal, we're going to have a weight, and then clearly we have a pushing force. But if it's moving at constant velocity, that implies that there must be some counteracting force, a friction force that slows it down. When I get rid of the pushing force, I'm going to have a very similar free body diagram. But now, without the pushing force, there's just a friction force acting opposite to the motion, gradually slowing it down to rest. All right. So that's it for the multiple choice section, and I'll do the free response in the next video.